Okay, this is problem 6.8.7, and we have a long-distance trucker traveling 108 miles in one direction during a snowstorm. The return trip in rainy weather took 3 hours less time and was accomplished at double the speed. And we want to find the speed going. Okay, so this is a distance equals rate times time problem, and we know that because of those variables being given to us in the problem. So we have a distance, we have a time, and we're looking for a rate. Okay, so I think the best way to do these problems is to use a DRT chart to organize your information, and then you can pull your equations off of the DRT chart and solve it. Okay, so we know that our relationship here when we're talking about DRT is distance is equal to rate times time. And so what we want to do is think about the two things that we're comparing here. So we have the trucker is doing a trip where he's going, and then he's doing a trip where he's returning. So let's go ahead and make this row right here the going, and then let's make this one the return. Okay. All right, well, in both instances, he's traveling 108 miles, so the distance going is 108, and if you're going to return, then it's going to be 108. And the rate here, if we take a look at, actually, let's go ahead and do the time next. So it says the return trip in rainy weather took 3 hours less time, and that's 3 hours less time than the amount of time it took him to go. So we don't know the time that it took him to go, so we'll allow that to be t. But we know that the return trip took 3 hours less time than this. So 3 hours less time would be represented as t minus 3. Okay. All right, and then if we look at the rates, again, we don't know what the rates are, but they do tell us that the return trip was accomplished at double the speed. So if we let the going rate be r, then the return rate, double that, would be 2r. Okay, and now I'm going to pull off two equations because we have distance equals rate times time. So the first equation is 180, that's my distance, equal to my rate times my time. And my second equation is, whoops, that's supposed to be 108, not 180. Okay, second equation, 108 equal to 2r times this whole quantity t minus 3. Okay. So now we have a system that we can solve, and since we're trying to find the speed, ultimately, speed is r, then what I'm going to do is I'm going to go ahead and solve for t first so that I can plug that into my second equation, basically do a substitution there. And actually, the easier way to do this problem would be to set up a proportion here, to set up a rational equation with this. So let's actually go ahead and just solve both equations for t initially. So we're going to go ahead and divide by r. So we have t is equal to 108 over r for the first equation. And in the second equation, if I solve for the t, then the first thing I would need to do would be divide by 2r. And 108 divided by 2 is 54 over r, equal to the t minus 3. And then we need to add the 3. Okay, so this would be 54 over r, the t minus 3. I'm going to add 3 to both sides so that I get t by itself. So we're really looking at 54 over r plus 3. Okay, and over here, so this was for the second equation. For the first equation, we found t was equal to 108 over r. All right, now since we have t equal to this and t equal to this, we can actually set these two equations equal to each other because logically they should be equal to each other if t is equal to both of them. Okay, So I'm going to set 108 over r equal to 54 over r, and then plus 3. And at this point, we are going to need to clear the fraction because we're trying to solve for r, and r is in a denominator. So we want to get it out of the denominator. So I'm going to multiply both sides by r in order to clear it. So I'm going to have 108 equal to, over here, if I distribute the r, I have basically 54 over r times r plus 3r when I distribute that. Okay, and these r's will cancel, and what we're looking at is 108 equal to 54 plus 3r. And if we continue to solve for r, subtract the 54, we have 3r equal to 54, because 108 minus 54 is 54. And then if we divide by 3, I believe the rate here is 18. And this was, I'm not sure if it was miles per hour or kilometers per hour, but at any rate, on our chart, r was defined as the speed going. And they did ask us to find the speed going. And so the speed going would be 18 miles an hour. And that's it on this problem.